Welcome to the podcast. Thank you very much for coming along. Today we have Dr. Claire Bird and Mr. Prezant. So we'll just start with you, Claire, if we could, just a little bit about yourself and how you got started in the industry.
Yeah, hi Phil, how are you going?
Good, thank you.
Thanks for inviting me along. How did I get into the industry? Well, my background has been a very long history in environmental science. I first got into environmental work back in the early days of the early 1990s when I became part of an environmental cooperative, which I ended up being a co-director of. And most of our work was looking at much bigger biological things than microorganisms. And we were doing things like managing ecology projects and projects where local communities wanted to get involved in managing their local environment for wildlife and for aesthetic purposes as well. And from there, I actually decided to go back into education as an adult, having completed a microbiology degree in 1980 and then stopped when I had children. So from there, I went back into learning and developed a stronger love for all things environmental and ended up doing a degree in environmental science monitoring and management. So at this point, things started to move away from bigger things to smaller things. And I became very involved in atmospheric chemistry, which is quite different to what I'm doing now. And through that, ended up doing a PhD originally in atmospheric deposition of nitrogen species into groundwater from the air. So we were looking at quite different. And so that went on for about 9 months to a year, and we didn't get the funding we were looking for to complete the project, and the project was put on hold. And so I ended up going and contacting a colleague at another university who was advertising for somebody who had a background in microbiology, and also a background in aerosol science. And there really weren't very many people who had done both. And that's really how I kind of fell into it. So the degree ended up including a lot of things on bioremediation and microbiology, and also in meteorology and atmospheric chemistry. And then from there, I ended up focusing on characterising airborne microorganisms, and that was using a lot of DNA technology.
Okay.
And then went into academia. I was very lucky to be brought to Australia by my then PhD examiner, wonderful guy called Andy Ball, who's now actually at RMIT. And Brad knows Andy as well and has done work with him. And I came over here to set up the bioremediation laboratory, biotechnology research facility at Flinders University. Spent about 4 years there and ended up doing more and more consultancy. Found my way in consultancy, and then somebody said, "Can you come and have a look at a mouldy building?" And I've never looked back since. So there we are, long story.
So was that a commercial building or a residential building?
That was a residential building, actually,
Okay.
Phil, yes. And it was a problem with a soil revetment behind a retaining wall in a 2-storey building.
Right.
One where I think somebody was trying to dry the whole suburb because there was no vapor barrier behind it. So that was the introduction.
That was that dry spell back in 1992. All right, okay. Well, that's interesting. I've got a few questions on there before we move on, if that's all right, Brad. So back in the 80s, you said you got your degree back then. Then you started moving. You come to Australia. What year did you come to Australia?
2005.
2005 from England?
From the UK, yes. Indeed.
Yeah. And so have you found, since you've been over here, the microbiology indoor science has grown since 2005? Is it something that's rapidly growing, or was it sort of there prior to?
That's a really, really great question. I think prior to that, it was very, very firmly established in academia in terms of the microbiology side of things. I think Brad will have some very good perspectives on this, because obviously he sat in that commercial space for a lot longer than I have and would know what the demand was like. But from where I saw the change was certainly when I first moved to Brisbane in 2010. I moved up here in the attempt to set up an indoor air quality division for a company at the time called Pacific Environment, and the demand just wasn't there. People weren't aware of it in the people I was speaking to, because I hadn't really identified what was going on in restoration, and it was much more looking at what we actually call in the scientific community bioaerosols. That means any airborne biological material. And it was more around places like compost works or occupational exposure, where people were handling materials where they were concerned about being exposed to them. So I think Brad's probably a good person to speak to that one, just because he's got that sort of very long history in the commercial sector.
Okay. Well, what a great segue. Brad, how are you?
Thank you, Phil. Welcome. I was totally absorbed listening to Clarence's story, so a tough act to follow.
Well, again, this is it's something new. People don't understand that this is only a new sort of a sector that's coming through, like last 10, 15 years. So it's really started to take off. So, all right, Brad, a little bit about yourself and how it all started and where you are today.
Well, my story starts in the U.S. I was a couple of years out of uni. I was making my living as a cabinet maker at the time, or whatever odd jobs I could pick up, sitting around the kitchen table. And someone said they were going to school to study occupational hygiene, and they were very excited about their program. And I had long had an interest in environmental issues, and it just seemed absolutely perfectly right up my alley. So I ended up in a master's program in public health, where I studied mostly what's called in the US industrial hygiene, and probably aptly named because at that point I was focused in the late 70s on industrial environments, manufacturing, mining, that sort of environment, as opposed to what you might think of as the more typical work environment of today, or building sciences. But my background was strong in epidemiology and biostatistics and research methodology on the epi side and public health side. But then on the occupational hygiene side, we learned all about ventilation and physics of air movement, and we learned all about chemical toxicology. And at the time, there was just a lot of increasing awareness in the early 80s with things like asbestos and eventually lead paint. And then mold and indoor air quality started coming to me in the 80s, when it was something that nobody else wanted to deal with and was very non-traditional for occupational hygienists to deal with. And there wasn't very much understood or known. So my first exposure with mold type problems came as a small subset of the indoor air quality and ventilation related work I was doing with what we used to call sick buildings. Buildings where people were complaining for some unknown reason. And a percentage of those might very well have been because of poor moisture management and mold or bacterial growth. And a lot of others were related to ventilation aspects. But that became an area of specialty for me. So I'm one of, I think, 50 people in the world to have an indoor air subspecialty certification through the American Board of Industrial Hygiene. At one point, there was an opportunity to not only become a certified industrial hygienist, but get this subspecialty in indoor air quality. So that was something I was very passionate about. And somewhere around the late 80s and 90s, I had taken a course with a very well-known woman in the US, Harriet Burge, on sampling for mold and microbials in buildings, which was a real niche area in the 80s in the US. And I had the equipment, and every so often, maybe 2 or 3 times a year, another industrial hygienist would call and say, "Hey, I hear you have the equipment and know something about mold. Can you help me on this air quality project I'm working on? I think it might be a moisture problem." And of course, in the 90s in the US, this really all exploded. And suddenly work involving assessing buildings with moisture damage became something not that was once or twice a year or 3 times a year, but 2, 3, 4, 5, 10 times a month. Wow. We also had an epidemic in Seattle where I had started a company, a consulting company in 1987 with a laboratory, a training division, and a consulting group. So I had about 25 employees for that 20-year period. And we were doing a lot of mold related work. coincident with, I guess you could say, some shoddy construction practices that were happening, where the exterior insulating systems were failing and water was infiltrating the building envelope and bleeding through to the plasterboard on the interior. So I became very involved in that. I chaired a subcommittee of the American Industrial Hygiene Association on microbial growth, and then became the chief editor of a publication called Recognition, Evaluation, and Control of Indoor Mold that was published by the AIHA.
Mouthful? That one's a mouthful.
That's a mouthful. We used to call it the Green Book. And in the last year, a new edition has come out. It's been, the original edition was published in 2007, the edition that I edited. And a new edition has just come out in the last year. And it's a comprehensive standard of care guidance document for occupational hygienists. So when I left the US in 2007, I sold my company, moved to Europe, lived there for several years, and then immigrated to New Zealand. Didn't do anything related to mold for several years, just did epidemiologic research on occupational health topics, panel beater exposures and exposures to chemicals in shipping containers when they were opened up after being fumigated. So things totally unrelated. And then after a few years, it seemed like there was growing interest here in Australia. So I did a course for the AIOH, the Australian Institute of Occupational Hygiene, initially a half-a-day course, and then I did a full-day course in 6 capital cities here in Australia, and about, I think, 175 people came through that course. There was tremendous interest. This would have been about 10 years ago, 12 years ago, here in the topic. So occupational hygienists were just kind of getting their hands around the issue. So it was a great opportunity for me to become recognized for my expertise that I had kind of brought from the US over here. Wow. So that's basically how I got involved in the issue. So it's been an interesting journey, and having had the experience of really growing with the industry in 2 different countries, I also have the, you know, the connections and the people that I met along the way in the US, as well as the ones here. So it's been a lot of fun, and I've gotten to know a lot of different people from different communities. Obviously, learning about the restoration community and the restoration process has been really critical for me. And also learning about the architects and the building science has been fascinating, because at least in the US, I used to do a lot of my assessments with a building assessor, because if I was opening up the interior of the building to look for mold in the wall cavities, they were anxious to see the building envelope that they could see through the opening I was making. Yeah. So usually they were making their own openings on the exterior of the building that I was peering through to see the backside of the interior sheathing, and I was opening up the interior of the building and they were looking at the backside of the exterior sheathing. So we worked together. So I learned a tremendous amount about everything from flashing detailings to moisture movement and the like, and really broadened my background into the building sciences. More recently, I've become involved with looking at infection exposure indoors, kind of returning to my roots as an indoor air scientist. And I've gotten involved with developing a risk calculator for COVID exposure, and then also assessing buildings for the risk of infection and transmission of COVID. So there you go. There's kind of how I got here.
Okay, well, try and break this down a little bit. So, look, it's a lot of way over my pay grade, the majority of this. That's why we have these conversations to get more information. I was over the States a couple of years ago, and I see that they're building houses now just with OSB as their structure. That's it. What are you thinking of that? Like, what's the theory, the thought behind that, other than price?
Well, it's quite interesting to move from one country to another and see the differences in both residential and commercial, more so the differences in residential construction, how houses are built. Yeah. Because in America, for example, double brick, it's like, what's that? I don't think I ever saw a house built with
Okay.
double brick construction, or you walk into a house and you see a vent in the wall and you ask, where does that lead to? And well, that's just the vent into the wall between the bricks, it's like, what? So there are some pretty significant differences in how people build houses, but there's certainly some commonalities. I mean, anytime you build a stick type structure, a framed structure, you need some type of diagonal stability. And while they used to do that with strips of wood diagonally placed against the rectangular framing, in the US, they used what's called oriented strand board, or OSB, which is a very large chip board compared to what we call particle board. And that particular product is not frequently found here, but it just provides the exterior sheathing in some fashion to give the building that structural stability. But like other manufactured wood products, OSB, when it gets wet, will swell, and the degradation that occurs from mold is rather rapid, far more rapid than you would see if you were dealing with a solid wood product, or even a laminated wood product that's solid wood. So something like plywood, you've peeled off solid wood and you're gluing thicknesses together. But OSB is more of a jumble of chips that are compressed and pressed under heat and pressure. So a lot of the molds, the filamentous fungi that we normally deal with, the stuff we deal with in buildings, they really go to town in a matrix like that. It's easy for them to work their way through the material. There's a lot of stuff for them to metabolize, all sorts of crushed cells and cell contents. They don't actually have to be specialized fungi capable of digesting both the glues and the cellulose in wood, because they have so much other food available in the matrix. So it's a quick to degenerate product if it gets wet. So we do see it on the exterior buildings. It's a lot better than wax coated plasterboard for that application. I can tell you that. But it has its vulnerabilities.
So the other thing I wanted to have a quick chat to you about was, you mentioned building science, moisture movement. Like the building science that's available for us in Australia is American based. Is there an Australian based building science sort of course outside of university, or that you know of?
Yeah, I don't know of many courses here per se. There are certainly individuals who specialize in these types of issues. And there's always specialty architects who understand how buildings should function and design remediation plans for buildings that have failed for one reason or another. So there are certainly architects that know very, very well how to properly construct a building and manage the liquid water and the vapor water that building envelope is going to be challenged by here. There is a lot of resources available in the US, in a country 5 to 10 times the size, no surprise. So I certainly have drawn upon the resources there, people like Joe Stiebrick and Building Science Corporation and other people like that who have great resources. But there's certainly some professionals here who are quite knowledgeable.
I'm just trying to work out, there's obviously the indoor hygienist that goes out and has a look and tries to identify issues, problems, and then do the testing. Then you also have the remediation teams that go through trying to get that understanding as well. So something we probably need to look at it, seeing how we can do that. So look, again, thank you very much. It's great to see you both come from different backgrounds, virtually for the same end goal as the what's happening in the environment, indoor, movement of air, whatever's going on. So the exposure levels, and we're lucky enough to have you in this country, in this industry. So, it's extremely lucky. So I guess moving on from here, what are you currently doing at the moment? Like, what's the main projects you've got? Obviously, you're doing a bit of stuff with COVID, Brad. What about yourself, Claire? What's keeping you going at the moment?
My main focus at the moment has been setting up our laboratory.
Okay.
And that's been been established now for just coming up to 2 years, and we've taken quite a different approach to the way that we think about our samples and what we look at them for. So we've had to do a lot of process development, software development, and those sorts of things. So yeah, that's been keeping me pretty busy. That's going very well. We're doing some consultancy. We tend to sort of take on specialist jobs rather than, I guess, general ones. But behind the model that Litmus is running is that we're actually working with other collaborators. So for a lot of the work I do, I work alongside other organisations rather than try and project manage it myself or be the only person on the ground. I'll often bring other people in that I know through my network in the industry and even through my time with IAQA Australia, and the people that I've met through that. I'll often include those in a lot of that work. So that's what's keeping me busy at the moment.
Yeah. So, I mean, your backgrounds are different. I guess you come across things that you said you need other professionals to help you with. Can you elaborate on that? What types of things have you been seeing or you're looking at that you might bring somebody else in?
To give you an example, I'm looking at doing a project at the moment where a lot of the items involved are very valuable, and we've got to look at what the right conditions are and how we maintain those conditions from a mechanical point of view, so that those items are protected. So that's an example of a project where I will bring in expertise of somebody who has a lot of knowledge in the mechanical engineering industry or the HVAC industry, because I don't profess to hold that knowledge myself. There's other projects where I want a specialist in a heritage building, because I don't consider myself a building specialist to the extent where I can make recommendations around rectifying a building that's got heritage value. Yeah. So again, I will bring in a specialist for those types of projects.
Yeah, and again, that brings up another great point, is that no one knows everything, and it's that network that you can grab, and that's the same with restoration. It's all about networking and finding the right people. So 2 years with Litmus. How did that all get started?
How did it start, or why did it start?
Well, I know you've had a few positions, and now this is your own little thing, and going well.
Yeah, very, very well. Yeah. I'm really, really loving it, and yeah, it's just been really nice to have the shackles taken off, because I am not a specialist in asbestos like many occupational hygienists actually are. It's meant that a lot of the times when I've worked within other organisations, they've had a specialism in asbestos. Asbestos has really been their main revenue stream.
Right.
So when a position becomes available for a new staff member, they get pulled into asbestos. So it really is very difficult to grow if you're sort of, I guess that small fish in a big pond.
Yeah.
That said, I mean, I've had some fantastic time working with all of the organisations I've been involved with probably over the last 10 to 12 years, and gained a lot from it, and still work alongside all of them.
Yeah.
But ultimately, it was a question of me wanting to be able to set a laboratory up, which I was finding, people say, yeah, of course you can do that when you get here. And I get here, but then, there was never the resources for it and so on. So in the end, I decided, I've been speaking to a young man called Michael Shepherd. Michael was chairman of the Asbestos Industry Association for a very long time, and he's on the board of directors of the Australian Institute of Occupational Hygienists. And him and I have known each other for a number of years. And I said to him, how about, you've got an asbestos laboratory, you're very well established in your industry. How about I bring the mould in and we grow that between us? And that's what we started doing.
Okay.
And then Michael was fortunate enough to acquire a transmission electron microscope, which I know Brad can talk a lot about.
I've seen that machine. It's quite impressive.
Isn't it amazing, hey?
Yeah.
So I just said, look, you focus on that. I'll actually physically move the mold lab to another location so I can grow it, and here we are. So
well done.
That's how that happened.
And yourself, Brad, moving along? More consultancy now these days? Is that what you're doing?
Yeah, I have always worked with insurance companies and remediators on really problematic or high value loss situations, both from a moisture and a mold perspective, and also from a sewage perspective and bacteria. So I'll do projects that relate to that. Not so much routine PRV type things, but projects where there's ambiguities or there's multiple contamination, perhaps with sewage and with chemicals. And then I also do a bunch of work related to smoke and particulate contamination that would result from bushfire, or distinguishing a bushfire loss from another type of a fire-related loss. Sometimes that question comes up in an insurance context: is the damage as a result of an external pit fire, perhaps, or a downdraft from a fireplace, or some other type of kitchen fire, or is it related to the infiltration of bushfire smoke? So I can explore that through the use of sensitive methodologies for analyzing the deposited particulate. So I'll do projects like that. I'll do general indoor air quality projects. And then I do some work with lawyers where there's litigation involved. So large commercial buildings or large multifamily residential, where an opinion needs to be rendered on the degree of contamination or the extent of remediation. I obviously work pretty closely with different remediators where I might have a project where there's questions about whether or not it's able to be remediated or not, and how extensive that might be. So I might work with a remediator who would do a test portion of the residence, say, or the commercial building, and see how extensive the remediation would be and how much material might have to be removed, et cetera. So I do a real variety of different things that relate to the restoration industry.
Okay. What are you seeing? Because we've had the fires, we've had the bushfires, and we had the rain event. What are you seeing in those areas? Are we still looking after the bushfire properties at the moment? Are they being handled, or have we got past that now? Like that was this year, wasn't it? Start of this year. So
yeah, I mean, a lot of the issues with the bushfire properties, especially the ones that were completely destroyed, had to do with residual asbestos.
Right.
And I've brought some of the technology that I used in the US with me here to Australia in terms of looking for asbestos contamination. So for example, if not so much focused on the bushfires, where we're talking about debris contamination and cleaning of debris, but if we talk about, say, a typical home where a contractor might go in and remove a bathroom because of the mold, for example, but if that contractor doesn't realize that there are cement sheets that contain asbestos, and they demolish all of the asbestos sheeting unknowingly, without having first identified it and tested it, then you have a situation where not only might you have spread fungal contamination throughout the building, but you might have spread asbestos as well. So I brought some of the technology from the US that I've used there to do those types of assessments that I think are much better than some of the techniques we've used here in Australia.
Okay. Can I just ask a question on that then? If they're same scenario, bathroom, what's the process of detecting on soft furnishings or hard surfaces throughout the property? Like, what's the process there? How do you go about determining that the whole property has been contaminated or not?
Well, it's similar to doing any type of, if we're doing, let's say, if we're trying to find any fungal contamination, we'll look for hard surfaces that you could take a biotape lift off from, where a sticky type tape will remove the particulate on the surface, and it could be analyzed by Claire under her microscope.
She's done with asbestos, she said.
And with asbestos, it's done a little bit differently, but either you're using some type of a sticky tape lift approach, or you're using some type of a micro vacuum approach, or you're using some type of a wipe approach. So one of those three, depending upon what you're looking for and the technology you're using to detect it, is going to be used. So we either are going to touch a hard surface with a sticky tape, we're going to suck the particles off of it with some type of a cassette and a suction source, a vacuum source, or we're going to take a wipe and wipe a known area, perhaps a 10 centimeter by 10 centimeter square surface, and then somehow extract, if it were asbestos fibers, extract the asbestos fibers from the wipe that you've used to do that. So there's a lot of different ways that you could approach that, but usually for assessing that type of particulate contamination, one of those three ways is going to make sense.
Sorry, just on that, there's a reason behind this, but we'll go there later. Is there a mathematical formula that you're sort of coming up with to determine, because you're not obviously going to tape lift every square centimeter of the property, take air that maybe the particles are too large to move, white glove, whatever you're going to do? Is there a way, is it a visual thing? Like, I say this for a friend. Let's go down that pathway. For a friend of a particular problem that's happened, and virtually it's been said by visual that the whole property is contaminated.
Yeah.
Friends come to me and said, now we're going to court.
Yeah.
What's the process on that?
Well, there's good news and bad news on that. The good news is that the process is often somewhat standardized. So something like the ASTM methodology, American Society of Testing and Materials, there may very well be an ASTM method or some other type of method for doing a tape lift for fungal analysis, or doing an asbestos analysis, or something like that. So the methodology from one lab to another, in theory, is going to be standardized, so that each lab is, in theory, also going to give you the same result from the same type of a sample taken using the same sampling protocol and the same materials. So the good news is that that piece of it is standardized. But then the actual sampling design, how many samples, where you take them, that sort of thing, there's nothing standardized about that typically. So occasionally there's some guidance that's offered through something like a regulatory agency, but often that's something where you're trusting that the person who is the scientist who's designing that sampling plan is designing something that's robust enough that it's going to stand up to peer review and potentially criticism, and not get thrown out of court if it ends up going in that direction.
Right.
So before Claire or myself or an occupational hygienist engage in a sampling exercise, we're going to sit down and we're going to say, okay, what are our hypotheses here? What are we trying to prove? Where do we want to do the sampling? How do we avoid bias in that sampling so that we're not sampling areas that might be more likely to be positive for whatever we're looking for, or less likely to be positive for what we're looking for? So we would want to design a sampling plan that was free of any bias in that regard. And then we're going to want to take enough samples that, as you point out, if you're taking a 1 centimeter by 1 centimeter surface in a large residence, how many of those 1 centimeter by 1 centimeter surfaces do you need to take to have valid, reasonable results? So there are actually, for some sampling methods, there are statistical guidelines where you would follow the guidelines in that regard. But generally, whoever does the sampling has to design a pretty reasonable sampling plan that balances out gathering the information that's needed with the cost and extensive time involved in doing a very, very extensive plan, which perhaps would be so expensive that nobody could afford. So you're looking for a balance there.
So what, is there a way, I suppose, to recognize, because if you're a homeowner, you can do any repairs in your house yourself. So you might cut asbestos, drill through it, whatever it is, not patch up, not do anything. 5 years later, 10 years later, you've put a piece of plasterboard over it. let's say you have a water intrusion, you've got mold growing, and the remediator comes in, or someone comes in to do sampling to have a look around what's going on. They cut that, they notice that that asbestos sheeting has been damaged. Is there a way later for, I guess, insurance purposes to identify if that person has inhaled some of those fibers, I suppose, from that event 5-10 years ago? Or is it just all bundled into one? You're the remediator, you're the IEP that's damaged that wall, so whatever happens from that point on, that's your problem. Have you ever come across that?
I haven't. As such, I guess the question you're asking is, can you link exposure 5 or 10 years later to an event previously? Is that what
Well, I suppose so, yeah. I guess that was what you'd have to look at, wouldn't you? The exposure levels and the time frames. It's just that these, asbestos, and again, it's going to get more and more regular. I hear it a lot. It could be the electrician coming in to change a socket or something, the plumber coming in. Now, plumbers aren't the tidiest people when it comes to works inside the house. So we'll go to many places where the plumbers bashed a hole in the wall to try and get to the leak and left everything all on the floor. We get there, so there is some exposure there. But again, 20 years down the track, if someone dies from, exposure to asbestos, and they go, well, I had this, problem back 20 years ago, and these are the companies that were on site. How do we sort of go, well, this could have been caused from something else? Is there a percentage there? I don't know whether I'm really explaining it right, but, this is going to be some factor for down the line. I know. Have you thought about that or not?
I think where you've got cases, I'm thinking here of the James Hardy issues with asbestos, where you've got a very large or significant number of people that have been affected that can be linked to a particular product in that case or process. Then I think that may happen, but on an individual one-by-one basis, it's very difficult to prove or disprove that person has not been exposed to asbestos or to whatever form of contamination it may be, lead-based paint, PCBs, mold. It's very difficult to prove that hasn't happened at a different time or a different place. What are your thoughts, Brad?
Oh, I think we're most challenged when we're asked to try and create a time history of anything. If we're asked, we come into a situation where perhaps there's been multiple water loss incidents, and we're being asked, is the mold that's present today the result of this flooding incident or the result of this leak from the shower pan that dates back 5 to 10 years or a previous flooding event from something like that? That becomes extremely challenging. It's one thing to characterize. I think, Claire and I are often asked to characterize the current situation in the environment. So if we're talking about mold, what we're really being asked to do is to say, okay, there was a water loss and there was fungal growth in some portion of the residence. We'll choose a residence. To what extent has the fungal particulate associated with that growth distributed throughout the building? Has it moved from the room where the incident occurred, or is it not even distributed through that room? Is it simply on the material that became moldy? Or has the material that became moldy shed so much fungal particulate that not only has it contaminated the surfaces in that one room, but it's moved through the entire residence so that rooms, many meters away have also become contaminated with that fungal particulate? And should the scope of remediation include collecting, i.e. remediating, all of the condition 2 surfaces throughout the residence? So that's characterizing the current environment. But then if you said to us similarly, well, the mold that you found, 3 bedrooms away, 25 meters down the hallway, you've described and told us that your samples indicate that that's a condition 2 situation. It requires a condition 2 clean. Does that mold derive from the shower pan that was down the right side of the hall that got moldy, or does it derive from the flooding from the tree branch that came through the roof in the bedroom located 10 meters down the opposite side of the hall? We're often asked questions like that. And this just typically, I mean, unless we get lucky and the shower pan grew only Chaetomium and Stachybotrys, and the water leak grew only Penicillium and Aspergillus, and we could see the difference between them very clearly. Generally, everything is all mishmash together, and they both grow a little. They grew a little of each, and we're not able to say that the damage or the condition 2 situation in this intermediate room is the result of A or B. We simply can say this is the description of what it is now, but we're unable to help you there. And occasionally that differs. So occasionally, you know, we'll have a piece of wood where I could submit it to a laboratory like Claire's, and they'll say, clearly this is long-term fungal damage. This is not something that could have happened in 8 to 10 weeks. This is years and years and years of Serpula lacrymans degradation of the wood. That's a very slow, long process. And this is definitely not connected to the water loss incident from 10 weeks ago. So sometimes we can do that, but often we're challenged to the point where we're unable to do that. And I think it's really important too, is maybe now is a good time to bring this up, is that even though I have a background in public health and I studied plenty of epidemiology and toxicology and dermatology and all sorts of lung diseases and all sorts of stuff relating to people and health, what we really do is we diagnose or we characterize buildings. And when I'm asked, what is the risk of this situation to the health of the occupants, I always say, listen, my job is to characterize the building, and that's what I'm doing. And if I give you a report that characterizes this building, you could bring it to a primary clinical healthcare provider and ask them if this is appropriate for you. So I try and sidestep whenever possible the issue of what is the connection between this environment that I'm characterizing and someone's health. And if I'm forced to do it, I feel qualified only to do it on a group basis. So I feel I might be qualified to speak to a sensitive population of atopic persons, or a pregnant woman, or a normal working adult. But I try and avoid ever tying to a particular individual, because I have no idea of their clinical conditions, their health status. Only somebody who could examine them would know that. So I think all of us, even those of us with a background in health, want to make sure that our attention is focused on characterizing the building and not making that mistake of stepping from there to the person. And of course, you know, you as remediators, you're always in close contact with the people in the building, and they're always asking you, what does this mean for me? So it's very tempting to try and answer that question, but I think it's really important that hygienists, building biologists, remediators, anybody who operates in this sphere understand that if they're not clinical health professionals, that they need to, you know, remind everyone around them that they're characterizing the environment, not the risk to the person per se.
So I guess you'd see that a lot more, in a commercial environment where there's a lot of people, a lot of different types of people. You're talking about the air conditioning systems, you know, what people bring into the building materials. Is that what you're talking about when you're talking about the environment of the building?
Well, I'm just talking about the indoor environment that's represented in what it is that they breathe or touch or somehow gets on their skin. I mean, we could be talking about I deal with all sorts of things. I might deal with arsenic in the soil and the infiltration of that soil particulate into the residence, or a chemical pesticide that's infiltrated, or whatever. Okay. But if we just want to talk about mold and fungal particulate, we're really talking about just characterizing the building and the extent to which that could cause an exposure. And generally, when we talk about particles, we're talking about inhalation. We're talking about things that float around in the air that you breathe in, that either deposit and cause damage in the upper or lower respiratory system, or use that as just as a route of entry to get into the body and get into the bloodstream and somehow get transported somewhere else where they cause problems. But that's what we think about when we think about buildings and health. It's generally focused on the inhalation of foreign materials.
Right. What about yourself, Claire, when you go to those things? What sort of instruments are you using to analyze?
Yeah, well, that's actually a good question. One of the things I'm picking up on what Brad was speaking about earlier, and we were asking the question of how do we evaluate whether something was a pre-loss condition?
Yeah.
Is this something, and this is a really critical thing that we're going to be focusing on two things. One of them is, as Brad rightly says, the building assessment, but the other side of it is the health assessment. And I see this as almost being a threefold question. So the first question I have is, we haven't remediated this building yet. Our focus needs to be entirely on the condition of the building and what needs to be done with remediation. And the questions that we ask as assessors and the instruments that we use in the field are designed to make that decision. So where we're looking obviously for moisture that may indicate we'll have fungal growth on a surface, we'll obviously be looking at history. And one of the big things that I find is a major issue is that very often by the time we get to site, that building has already undergone a substantial extent of drying. So whilst we will bring a moisture meter to site to help us identify the areas where we may need to look for the mould, either through destructive testing or more intrusive investigation, if we're starting to think about a single threshold as a wood moisture equivalent value that we're saying if we've got about 15 or 17 or 20% WME, depending what we're asking, that's going to be the golden bullet for us. If that building has been drying for a period of 6 months before we get there, that doesn't necessarily let us know where that mould may be hidden and no longer visible.
Yeah.
So we obviously use moisture meters, we obviously use thermal imaging cameras, but it's really important that people understand the limitation of those instruments, which very often I really am not sure that they do. Particularly, things like you get your moisture meter on scan mode, and there's a great place for that. If you're scanning a wall, you can look for high points on that wall, whether it be at the base of the wall or at the top of the wall, where you can see an elevation that's not characteristic of that particular material. And then you can test it further. So all of these instruments have their place, but unless you really understand what can be giving you those readings, you may just be measuring a metal stud in a wall behind where you've got your meter. So we do bring the conventional instruments with us. In terms of evaluating pre-loss, one of the things that we do use is we very, very rarely to disastrous consequences with a fire brigade, but we do employ flow visualization. We can use either smoke or you can use air pressure differential measurements to get some idea of which way the air is flowing in that building. So if you've got, as Brad was saying, a shower on the right hand side of the hallway and you've had an escape of water in there and you know where the mold is localized, you can start to think about the air pathways and whether it be just along the corridor and into the bedroom in the corner, or whether you've got a return air vent just outside that bathroom that could be transporting that fungal particulate elsewhere in the building. One of the things we do is we actually, probably our most important two instruments are our eyes and our noses.
Yeah.
And again, I think we've done some discussion, as Brad was just saying, about our focus is on building assessment, but the actual pointers to a building being particularly bad for health are things such as the extent of water staining, the extent of damaged materials, the extent of mold staining, and the degree of the odour. And all of those things have been shown to be related to health effects. So in terms of assessing a building's health, just taking measurements alone without using our organic instrument of our own senses, it can lead us awry.
How are you finding these new handheld instruments that are sort of just coming to the market now to gather particle size? Are you using those sorts of things, or you wouldn't use those? They're too basic for what you're trying to do?
Well, if I could add something on that topic, Phil. I think particle sizing instruments can be very powerful and useful. A particle counter, an optical particle counter that sorts into the various size classifications may be a useful instrument in an indoor air quality assessment. But I think there's a lot of problems, as Claire talks about, in terms of misusing instruments, where if someone is looking for fungal particulate, in their minds, they say, fungal particulate, that's probably between 4 and 10 microns in diameter. So I'm going to just follow my scale here on my instrument and assume that all the particles in the air between 4 and 10 microns are individual penicillium spores, and draw conclusions and make recommendations on that basis. And I've seen, even what should be people who would know better using a tool like that that's really not specific for fungal material, and drawing conclusions that are way beyond what the instrument is really capable of telling you. So I think with some of the sexy new technology comes misuse of that sexy use technology. And you need to watch out for that.
I couldn't agree more. I'm 100% with you on that one. So I was going to bring something up about, let me think about what it was. VOCs. So currently we've got a claim going at the moment where there's been a drum of diesel and petrol poured out through the whole property. So the biggest thing we're going to have is VOCs. How do we test? I guess it will come down to nose, but after we've used our chemicals to remove the bulk, do the cleaning, there's always that chemical residue smell that's going to be around. How do we, these are obviously affect people differently. How do we know that we've got it out of the soft furnishings, the wall linings, that sort of stuff? Is there a way we can test for that sort of thing?
Well, the VOCs, we actually have a couple of terms for that stuff. VOCs, the volatile components, are the things that dissolve in the air pretty rapidly. So if you think about water or toluene or something like that, if you spill it or it's in the air, if you came back a day later, it's unlikely that you would see that puddle on the ground. So all of it has evaporated in the air over that several hour or 24-hour period. Things like that are reasonably volatile, they tend to go away pretty quickly. It's the stuff that's more oil-like. And if you think about, say, a fire situation where you've got smoke and you have things that normally would not be gaseous at room temperature, but have become heated up and dissolved in the air because of the combustion process. So these materials don't want to be dissolved in the air, but they're forced to dissolve in the air by the heat of the fire. And then when they condense on something, they're going to go back to their I don't want to be in the air form. And now they're going to come off enough so that you smell them. You smell them over time, but they're not very volatile. And it may take a really long time for that stuff to fully volatilize into the air. So we don't think of them as very volatile compounds or volatiles. We call them actually SVOCs, semi-volatile compounds with much higher boiling points. And those things are much more difficult to deal with. And I'm sure for all the people who listen to your show who do fire restoration, they know that if you just try and cover up a situation where the smoke has penetrated into the wall cavities and those SVOCs have penetrated into the wood and the studs and the other porous materials inside the cavities, you're going to have that odor persist for an extended period of time because you didn't rip off the plasterboard and you didn't remediate all the wood back in there, and you're going to be in trouble. So
very good point.
That's the kind of stuff that you have to look at. And if you're talking about petroleum products, most petroleum products have a lot of those semi-volatile compounds in them. So if you have contamination with oils or greases or anything like that, that stuff's mostly not easy to get into the air, and it just sticks around and smells for a while. So you have to approach it understanding the chemistry and the physics, and realize that those things are going to stick around for a very, very long time. And Plus, when they evaporate, anything that evaporates into the air is really dancing between different states. So if it evaporates in the air, it's going to resorb into whatever material that it evaporated from, or it's going to resorb into some other porous material in that environment where it wasn't present in the first place. And then it's going to dance between being in its liquid form in the material and its sort of gaseous form or volatilized form in the air. And it's just going to dance back and forth between those two states. So it's almost like methamphetamine is also something that when you smoke it, quote unquote, or you heat it up in a glass pipe, you take something that's not intending to be in the air as a gaseous form, and you make it in such a form that it can now move around in that manner. And the moment it hits a cold surface, it'll condense on that surface. And then it'll start that dance going back and forth between being in the air and mostly being on the surface and coming off and going back. And so it's a tricky thing when you talk about remediating those environments, because somehow you have to collect that material. So we're back to the same thing we talk about when we talk about mold and fungal particulate, collecting all the fungal particulate as the purpose of remediation. So when you're dealing with something like this, it's even more problematic because it didn't just settle out from gravitational forces, it got sucked into a material and absorbed into it. And it's going to get a little harder to pull it out of that material. Perhaps the best analogy would be, since most of the people who listen, I would imagine, understand water and water restoration, they understand that it's one thing to clean up the liquid water, but you have to coax the water out of the building materials into which it's absorbed. And the only way to do that is to somehow get it to, dissolve in the air and pull it out as the humidity in the air with a dehump or something like that. But you're basically taking that liquid water from the material,
You're more
turning it
Australian
into a
than you
gas.
think, Brad. Hey, dehum. Hey, you're becoming Aussie.
Yeah, I don't know. I doubt that'll ever happen.
You say
But it's the same process.
Dehum, what?
It's tough. It's tough to get things out of materials they've soaked into.
Okay.
It's really tough.
So you okay? That's another subject. We'll bring that up on another podcast on how to remove the tricky things. So we had a effluence job not long ago, and it transferred from the boat to the car to the unit, and trying to get that out was a nightmare. It was, we heated it up. We cleaned it. We cleaned it 3 times. We couldn't smell it, but the owner of the property, the owner of the vehicle, that olefin nerve thing. That's once it's there, that's always there. So, and again, I'm not sure what happened to it after that, but yeah, it was just one of those things. So it's very difficult to do testing for it, and we try to smell. We go away. We get a fresh cleansed nostril and go in and smell it. We can't smell it, but they can. So it's one of those things that we have to deal with. So moving forward, what else can we talk about? We've got what else is going on? I know we're doing we'll cut this out. We'll cut this little section out. We've just been asked to do the COVID cleaning up here in Brisbane.
Yeah.
What are we doing with that, Brad? With you're doing the testing, or are you doing anything with the Queensland government there, Claire, with that?
I'm not, but I think the sad news about the cleaning is that we started out with this COVID stuff, assuming that we had this large droplet that was dropping out of the air onto surfaces, and all of the infection was driven by the sneezing, coughing, deposition of droplets, either directly or indirectly on people, dropping those droplets on a surface and having someone touch that surface and then touch their face. And that was the operating theory for how COVID was transmitted. Right. And of course, we now understand that that was totally wrong. And COVID is transmitted via small aerosols. And sure, it's transmitted via large aerosols if you're standing within, a meter and a half of someone's breathing. They're expelling lots of large aerosols and lots of small aerosols. But there's been so much information now that COVID spreads via an aerosol route, meaning that small stuff you exhale that travels a lot farther than 1.5 meters, that could be traveling all the way around the room or all the way around the gym. I mean, we had all these incidents in gymnasiums where people were absolutely socially distanced. There's no question that that was being observed, and the instructor became infected. So we know under many of those case studies that it was impossible that they would have been touching the surfaces. So it's obvious that we had a situation with aerosol transmission. So the bad news for everyone who's been doing all this COVID cleaning is that's actually the wrong thing to do. And if they just took all that effort and money and time and invested it in improving ventilation, they might very well have reduced transmission dramatically. So there's really not a lot of compelling reason. And I don't even think I've read any accounts, case studies of situations where people have developed COVID as a result of touching a surface that someone who's infected touched. Right. So that whole theory does not seem to be bearing up with experience and research and case studies. It turns out that it's just much more important to manage the ventilation than it is to manage the surfaces.
I was actually listening to I think it was the IAQA podcast, and they had they were talking about the schools in the States, and they're putting all these ionizers and all these sorts of things. What's your thoughts on all that sort of stuff?
Yeah, most ionizers are really, there is some good research showing that there's no positive effect, and also anything that electrically excites the air often will take any chemical contaminant in that air. And while the manufacturer might say it's going to break it down to carbon dioxide and water or something like that, you're going to get a full spectrum of breakdown from partial disassembly of the molecule to thorough disassembly to no disassembly. So very often you could take a irritant substance in the air and convert it to something that's even more irritating or more problematic. So most air treatment technologies are not recommended by most authorities. What's recommended is plain old filtration. Obviously HEPA filtration when possible, but other filtration is also useful. It just might not be 99 point something percent effective, but even, MERV 13 or 14, I mean, even these things that are not HEPA, but are significant filtration are going to dramatically reduce the particulates that are present in the air. So
what have they got in these properties where they're putting these people in the hotels and that? What sort of system have they got going in there for circulation?
Well, I can't speak about the hotel quarantine situation because I've signed a confidentiality agreement.
Claire.
So
tell Claire.
Claire can speak. I can only tell you things that are published in the news, but I can't tell you any knowledge or information I gained.
But Brad hasn't told me either because he's very good with his NDAs.
Right, a tricky situation. So
I certainly have seen some moves to change the pressurization of the hotel rooms so that the rooms are actually under positive pressure in relation to hallways, so the air doesn't move from the hallway into the rooms.
Positive air pressure.
Positive air pressure. Is that something you've seen, Brad?
Yeah, I think whether we're talking hospital, I mean, most of what we know about infection control in indoor buildings comes from hospitals. And obviously, when you design some type of an infection control ward or infectious disease ward, and we address this with SARS-1, with Ebola. So it's not like these issues are foreign to people who work in hospitals and healthcare as an infection control. So the way that you manage airflow in that environment is you create a significant pressure differential between the area that someone is infectious and all the other surrounding areas. And then you filter the hell out of the air. So pressure control, pressure management is certainly one of the key elements for how you address exposure, because the pressures are going to determine how and where the air flows. So if you depressurize, we're all familiar with negative pressure enclosures.
Yeah.
So if moving from the exterior inward to your containment, then from the containment outward. So those types of principles have been used for decades in infection hospital control.
Is there a number of air exchanges that we're talking about? Has anyone come up, like it has to be 6 or 8 or 10 air exchanges to move it through those filters, or is it just getting it through the filters? Like how do we know? Is there a way we can test what's going on in the air, the aerosols in the air?
Well, yeah, we could test aerosols in the air, although we can't really test for infectious live COVID in the air. We could certainly test for the particles, that because the COVID isn't free floating in the air as an organism.
No,
it's simply contained in respiratory mucus that you've exhaled.
Yeah.
And those particles are across an enormous size range.
Mhm.
So we don't exhale only one particle size. We exhale very large, very small, everything in between, super small, ultra fine, everything we exhale. And then as a result of exhaling it, those particles change once we've exhaled them. So if you have a small round liquid particle in the air, because the majority of that particle is water, you're going to get evaporation from that particle in the air, and that particle is going to shrink. So not only do we exhale a wide range, but once we exhale it, as it moves around the space, because many of these particles are not heavy enough to settle out from gravity. So they're just going to follow normal room air currents, and they're going to start shrinking over time. The longer they spend floating around, the smaller they get. So it's a pretty dynamic situation, you know, and they'll just follow room air currents. So they're too small to settle out from gravity. They're not necessarily going to settle out by electrostatic attraction to surfaces. So they may just float in the air for an extended period. So where that air moves is essential to understanding. And, you know, there are ways that we can see the way air moves. You know, we could certainly release theatrical smoke, and Claire talked about that earlier. And that fine particulate is fine enough that it isn't settling out, and it's just simply suspended in the air. So you visually see the direction the air moves. Or we could release a tracer gas.
Yeah.
You know, I've used a number of different gases for that purpose. Sometimes in an unoccupied building, I've even used carbon dioxide, where you build it up to a much, much higher level, like maybe a couple of thousand parts per million, as opposed to a couple of hundred. That's typical, but not a level of CO2 that's of any concern for health or exposure. And watch how that moves between spaces, or watch how it decays to calculate the air changes per hour. So there are a lot of ways that we can understand airflow and track airflow. It takes, you know, a bit of effort, but it's possible to do that.
So
Sorry, yeah, go Claire.
yeah, so coming back to Phil's question, is there a magic air exchange rate that we're targeting to ensure that's going to be dependent on the actual load of the aerosol in the first place? So if you've got a very small loading of an aerosol, then your air exchange rate to dilute that will be less than if you're looking at somewhere where, for instance, if you were in a hospital and you're in a ward that's full of COVID patients, clearly you've got a very heavily laden air packet, and that air packet's going to have to be diluted substantially more. So in a way, one of the big things that we're missing, and going back to probably almost 20 years ago, I was in discussions with the research department in Canada, who were trying to come up with real-time measurements and detection systems for picking up bioaerosols. Remember that term from earlier, but that was airborne bacteria or viruses that military staff may have been exposed to in the field. And we've actually got IAQA Australia has actually got Dr. Zahir Nasir speaking at our next Lunch and Learn meeting on the topic of real-time detection of bioaerosol. So he'll be able to bring us right up to speed in where we are and where we aren't. And unfortunately, we're still many years away from actually being able to measure anything in the air that's meaningful in terms of anything that's going to be a biological warfare agent, or even anything that's going to pose a significant infection risk. So, whilst we talked about particle counters earlier, they have our place in ensuring people aren't being exposed to a particular size of particulate matter. It's not targeting what's in that particulate matter. It's just saying that that could be a truck's just driven past the outside of your window, as opposed to being a tiny fragment of something that's damaging from a different reason. So, I think that in terms of air change rates, to come back to your question, what we want to do is control the levels of that particulate matter to the point where even if there was a virus in there, it wasn't going to be a risk. And that would be fine if we understood what concentration of virus in there was actually posing a risk, because we still don't have, I don't think, do we, Brad, an actual dose response number where we can say, well, we need to get down to 10 viral particles per cubic metre of air to class it as safe.
Yeah.
Again, until we've got that information and ways of measuring it, it's very difficult to find that sweet spot.
So what is the current measurement at the moment for the, I suppose, clearance of a COVID infected, whether it's a hospital ward or a hotel? What is the current methodology?
Well, there really is no specific guidance. I mean, in healthcare, you often see 10 to 12 air changes per hour in an area where there's risk of infection. But there's no specific guidance for COVID management. I mean, obviously, more air changes per hour are better. Yeah. And there's certainly confusion between whether or not you're when you call it an air change per hour, are you talking about a fresh air change per hour, meaning outdoor air that's completely uncontaminated? Or in a larger building, are you talking about return air that's come through the HVAC system, been filtered by the standard filters in that HVAC system? And let's assume they're not anything extraordinarily special. They're just typical bag filters that you would see in a commercial HVAC system in, say, an office building in the CBD. Let's take that air, and if we now mix 10, 20% fresh air in with that return air from the building, is that what we're talking about with air changes per hour? Because I think that there's some confusion there. I think that the guidance that facility managers for commercial buildings got early on in the pandemic was bring in more fresh air, don't recirculate air. So they might have, in a large commercial building, opened up their outside air ducts, spent lots of money conditioning the outside air, and thinking that it was best to take all that return air from the building and exhaust it to the exterior and bring in all this fresh air as a greater and greater percentage. But we also have no evidence that something like COVID is going to travel 20, 30, 40, 100 meters from room A back to the central HVAC system through the ducts, the return ducts, pass through the filtration, pass through the coils, pass through the fan, get blown down another 150, 200 meters of ducting, and get blown out into the room and actually carry live infectious virus with it. So it's not even clear that we need to worry about outside air as much as we need to worry about total air changes per hour, because it's likely that those total air changes per hour may be just as effective in reducing the concentration in the air of infectious material. So that's certainly something to think about. But, there's no specific guidance at all that's been issued on that. And for whatever reason, the health departments, both here in Victoria, Australia-wide, internationally, have really not come down in terms of those types of recommendations. Instead, they've tried to simplify things and not even address those issues by talking about a percentage of occupancy. So if you're in an indoor environment, you could have it at 100% or 75% or 50%. And they don't even talk about those types of issues. So we don't have guidance, truthfully, that addresses that.
So you've talked about the touch. Is there anything to do with dust, or like we've got people going in there and cleaning areas? They still need to be cleaned. Places obviously still need to be cleaned. There's transference. but when they're going in and cleaning, is it trapped in the dust? Have we done any studies on that? Is it?
Yeah, they've done some studies where they've attempted to certainly identify the genetic material, the the RNA associated with the COVID, with SARS-CoV-2. So you can do a study where you somehow pick up the dust and particles on the surface, and they look for evidence of the RNA, just like they would do in sewage. So we've had a lot of sewage testing here in Australia, where the government will suddenly say, hey, we're detecting it in this neighborhood. Perhaps there's an infected person shedding the virus and being caught up in this sewage. So with the same, with the same technology, you can wipe surfaces, and you could look for residue of the RNA associated with SARS-CoV-2. So, but there's problems with that. We're not even sure we don't know if that's living or dead, number one. And number two, we don't know if you touch a surface, perhaps 1,000th of whatever might be on that surface might transfer to your hand. And then you touch your face, and 1,000th of what you deposited on your hand transfers to your face. So we don't really even understand if that's enough of a critical dose to cause disease. Right. So there's just a lot of unknowns when we talk about that. Yeah.
Two things to pick up on that, Brad. One of them is that the whole, as Brad's described, the marker that we look for SARS-CoV-2 is actually RNA. And RNA, I'm not even sure at the moment we've got any idea how long that RNA itself lasts in the environment for, whether it lasts for 8 hours. We've got some measurements to show how long it survives on surfaces. But in terms of whether that indicates a live organism, as Brad has said, we've got no way of knowing whether that RNA is suggesting that organism's alive. However, one thing I would look to is that there's a lot of evidence around resuspension of bioaerosols from surfaces when people are moving through buildings and they're generally moving around. But most of that work's been done or conducted on environmental biological particulate matter rather than on infectious diseases. But certainly we do see substantial resuspension of airborne microorganisms from particularly carpeted buildings. The gentleman called Jordan Peckier, who I know Brad will know from the US, did quite a neat piece of research where he had people walk through a building with carpets and did some measurements, and then put a plastic covering over the carpets and had people walk through. And he actually showed that 90% of the biological material, microorganisms that we're exposed to in the indoor environment are actually resuspended from the surface of things like carpets and so on. So again, I would be very wary of drawing the bow at the moment to say there's absolutely no risk from settling onto surfaces, just because those things on the surfaces can then become resuspended. So if I've got somebody going in with a vacuum cleaner to a building where there's been sick people, I'm not sure I'd be that confident and not encouraging that material to become airborne.
Yeah.
And then spread around a building because of that resuspension of that material. So I do think if people are going in and doing cleaning, it's important that they think about their own personal protection.
Absolutely. Well, guys, we've come to the end of the time. It's gone quick, and I've written a whole page of stuff. So people can reach out to both of you. We'll put the details on the podcast link. For all the listeners, this is an ongoing thing, this COVID, the indoor environmental, that's something new as well. And again, as IEPs or whatever you want to call yourselves, restorers, we don't know everything. It's all about reaching out and trying to gather as much information as possible. And if you reach out to people like Claire and Brad, they've got a wealth of knowledge, and they've also got a large formation of people that they can draw on as well. So guys, I can't thank you enough for the time for today. Really appreciate it. Any last words, either of you? Or no? All good?
Right.
Just nothing of a technical nature. Just to thank you both for an interesting discussion.
Yeah.
And, you know, Claire and I, as scientists, as IEPs, whatever you want to call us, you guys keep us grounded in reality. You know, you're the ones who are out there doing the work. And in order for us to take whatever knowledge or information we have and apply it, we're doing that often through you. So that's, for me, at least, I'll speak for myself, but I think this is probably true for Claire. We're most happy when we could take that knowledge and information and apply it in a way that helps people. So the extent that we could be the link between the science and the practice is really satisfying and essential, and it's pretty much why we all work together. So.
Well said.
Agreed.
Yeah.
Yeah, I think Phil, it gives us a chance to apply practical services through scientific solutions, and I think that together we can do that, where neither of us can probably do it on our own. So thank you very, very much for inviting us, and thanks, Brad. As ever, it's fantastic to spend time with both of you.
All right, guys. Thank you very much. Ta. Thank you.